Good day. Our topic for today is about computer networks. As for the introduction, a system of interconnected computers and computerized peripherals such as printer is called computer network. This interconnection among computers facilitates information sharing among them. Computers may connect to each other by either wired or wireless media. As the objectives, we are expected to familiarize the different classification of computer networks, understand the computer system and peripherals are connected to form a network. As for the topics, the classification of computers. Well, computer networks are classified based on the various factors. Geographical span, meaning how big it is, what will be the coverage, interconnectivity, and how we're going to connect each of those networks. The third part will be how you're going to manage, and then how you could able to set up what we call an architecture. For the geographical, meaning it may be spanned across a table, ranging from a few meters, a whole city, a whole province, or even in the whole world. As for the interconnectivity, there are types of different topology, which will going to be clarified later a little bit. As for example, it's a mesh topology. Components of the words of network can be connected by each other differently in some fashion. By connected, we mean either logically, physically, or both ways. Every single device can be connected to every other device on network, making it the network mesh. Administration. Well, once you design your own type of network, you should know how to administer it. For example, you have 5 different branches and you have 5 different topologies. You should know how to administer each one of those different topologies like bus, trees, mesh, half mesh, full mesh, things like that. And obviously, the one in charge for the administration will be the IT manager, corresponding to how come those people will access it. In terms of network architecture, as for the client servers, for example, the Department of Marketing are not allowed to have files coming from the Department of the HRD. Similarly, the HRD cannot actually access the files of the accounting. In prior to that, the architecture network should have a limit of the types of the user for a typical client requests and so on and so forth. So network architecture actually bears what we call the form of security, the limitation of the clients or the user's level should be determined by our architecture. Okay, so as per applications, we know during this pandemic times, network application is usually use LMS. Since our LMS is an MS Teams, we could able to have a meeting in all of us using online. We can have a meeting using a server, a group listener, we can download movies, we can download songs or MP3s. These are the things that we could actually do. We can send a message, we could post anything that we feel that we would like to do. So obviously, resource sharing such as printer and storage device. Example, if I have a home, I have 5 rooms, and then in each room I have one laptop or PC, but I don't have 5 printers. I only have 2, so I need to share those 2 printers to the actual 5 computers. We can actually exchange message to emails or FTP. FTP is actually done inside the company, which we call it a file transfer protocol, which is just a very safe and secured ways of sharing files. Unlike in messenger that you could simply attach or email. It can be simply hacked, something like that. Or information sharing by using web or internet. Well, all of companies have internet. It seems that everybody is connected to the internet. But if you have an internet, you also have what we call an intranet. Internet is actually, those network are only inside. We could able to exchange a lot of data and files, but it's within the limitation of the companies. Interactions with other using dynamic web pages, IP phones. These are some of the few applications. Parallel computing, instant messaging. So these are the things that we're actually doing since the revolution of the Web 0.20 way back few years ago. The next one is a distributed processing. Due to the complexity of working big data, often the solution lies within the distributed networks, processing networks. Meaning, for example, you have a very limited bandwidth in the connection of your data, but you have 10 computers playing games simultaneously, right? So it's either one of those computers will slow down, but during to the idea of what we have now to our network devices, those issues no longer a big concern. You can have actually 5 of them are watching YouTube at the same time and at the same time playing, while the other 5 is actually playing games. There will not be any disturbances. It's only called what we call a distributed processing. So there will be no more simply only one. Okay, so for the network, as this theory has largely proven correct, over the last 4 decades, engineering strategies like distributed processing also have added the speed of the logical device for such an amazing. Before, way back few years ago, dual core, core to duo. Then later on comes what we call core i3, core i5, core i7, which is now in generation 9. It started with the generation 1 way back 2001. I'm sorry, that's 2004. So from that time, every 18 months comes another generation. Generation 1, 2, 3, 4, 5, 6, 7. At this point in time, generation 9 has core i9. So we have core 3, core i5, core i6, core i3, 5, 7, 9. And that's only for the Intel. Similarly to other providers like AMD for the IC, they have different. Similarly, A1, A5, A9, A10. So corresponding the same. For the core i9, that is equivalent of 30 computers way back before. If you have some around in 2010, if you have what we call a Pentium 4 or a Core 2 Duo, Core i9 is actually equivalent to at least 30 of that in terms of speed, processing. So that's why we keep on leaping as possible as fast as possible. Okay, so for the network criteria, we have to define what are those criteria. Number 1 is the performance. What is the response time? For example, I send a message to all of you guys in LMS, and then there's a delay of, let's say, less than 30 seconds, or no, milliseconds. The performance is actually has a delay time, so it's not quite good in terms of responsive times. So depending on the network more user on a network, slower the network will run. Transmission speed, that will determine the speed to be transmitted in bits per second. So, media types, hardware types, software programs. These are the basis for what we call the performance. For the consistency, that means if a normal response in 3 seconds, for a printing to a network response over 30 seconds, we know that there is a problem in the printer. So that should be the case that accuracy of data should be received. For example, nag-message ako sa PM and then you receive half of the message, that is no what we call consistency. For reliability, of course, reliable means everything that we're using have what we call MTBF, mean time before failures. A USB flash drive will have at least 10,000 read and write process before it was become a failure. That was 10 years ago. Now they have at least around 18 to 20,000 read and write before they could able to have what they call the MTBF, or the mean time before failures. So in an average, a common person uses USB for a flash drive probably at least 10 years. Yung common, yung ginagamit mo lang everyday. Yung once lang a day. Kung kayo gumagamit ng 3 to 5 times, probably less than 5 years. But if you randomly use it for sometimes, it will last 10 years or more than so. So the ability for the recovery is based on having a backup files. Obviously, so network ability to return the prescribed level of operation after the network failures. Loss of data non-existent or a minimum. So it's one of the main concern. And obviously the security. You have the files, but it is corrupted or is being infected. Either way, your data will no longer be accessible or visible. So there are a few types of what we call computer networks. Generally, distinguished in the geographical span. Personal area network, the most common, we call it the PAN. Smallest network, which is a very personal. Okay. The next one is a local area network. A computer network spanned inside a building or a lot of things like that. It's simply like a desktop, laptop, printers, and a basic server. Most common of LAN is actually a computer shop. Common yan sa local area. Okay. Next to that is a metropolitan area network. Generally, metropolitan area networks can connect, let's say, in office buildings, different buildings, or you can have a residential area or the whole barrio or city, or the whole university, or all of the government buildings. So metropolitan is quite at least a bigger than one. So these are the 4 typical type. The last one to the 4th one is the wide area network. As the name suggests, it maybe covers the entire province, the country, continent, or even the whole world when we say wide area network. For the internetwork, it's more on inside the company. It's scattered in the different countries, but their network is solely for their own usage, just like the military. No one could able to access it unless we are something like, you know, for example, the internet network of Sun Vehicle Corporation. No one can simply access it unless you are a member of that. The same thing with our government. These are internet network. Each of the department, let's say Department of DSWD, something like that, DPWH, they have their own internet network, but they are connected under one, obviously in the government system. If you're not a employee or a member of certain department, you are not allowed to use. Unlike the internet that everybody could able to access. That's a different thing about the network of the landman one as different to internet network. Internet network is more on the private or something like, which is not allowed to do that. For the last topic number 2, the technologies and the topologies. The data communication networks connecting various terminals or computers within a building or limited geographical area. The connection among the devices can be wired or wireless. Ethernet, token rings, wireless LAN using IEEE, and the standard LAN technologies. So as for the topic 2, you are expected to familiarize the different network LAN and the different network topology. Let's start first with the Ethernet. It's a widely deployed LAN technology since 1970. Luma na, no? It's actually very an old one. We no longer use that actually as of now. What we're using now is what we call a fast Ethernet. This is now the common fast Ethernet, which actually using Cat5 twisted pair cable, which uses CSMA CD techniques and techniques for the wireless Ethernet LAN. But this technology is actually quite old. But there's still a lot of companies still using the fast Ethernet. Still, if you could able to see that computers shops are using Cat5e or Cat5 to Cat5e, they are using fast Ethernet. Nowadays, you're using what we call the gigabit or the giga Ethernet. After it was being introduced in 1995, try to take note, that's more than 30 years from now. Oh no, 26 years. So, the gigabit Ethernet using an over the Cat5, Cat5e, Cat6 cables and over fiber optic. So it just simply determines the speed. The next topic would be the virtual LAN. Please do take note of what the words VLAN simply stands for a virtual LAN, meaning virtually connected. There are no simple wire. Uses a Ethernet which works on a shared media, create a single broadcast domain and one single collision domain. Introduction of switches to Ethernet has removed single collision. Wala na kasi tayo masyadong, as of this point, we're no longer using those what we call token. Although, but even switches cannot divide the network into separate broadcast domains. So virtual LAN is a solution to divide a single broadcast into a multiple broadcast domains. Hosts in one VLAN can speak in the host another. By default, all hosts are placed in the VLAN. So let's go to the topology. Here's the most interesting part. The most common is actually 5. Okay, let's try to redefine them. We have bus, star, ring, mesh, tree, point-to-point. Point-to-point is an absolute 1. But still, if you were asked what is point-to-point, we're going to discuss this a little bit. So both logical and physical topologies could be the same or different in the same network. Meaning, These different topologies can be used or utilized in of a company having two different topologies. It is allowed, but you should know how to manage the difference. Let's go to the point to point. Point to point is actually something like a computer to a computer and nothing else, or a PC to a printer, and there's nothing in it. It was actually an old topology which is not actually being used at this point in time. It was actually a old model or technology. On the bus topology, this is the most simplest, the most cheapest kind of topology to be used. Cheapest, affordable, you have it here. But since this is the most affordable or the most cheapest, and this is the most prone to failures. Once one of the line is this got a problem, all the device stop functioning. So this is not recommended. The next one is a star topology. Okay, star topology, which is actually utilized by some companies. It's actually a little bit affordable, considering as compared to bus. I would prepare to star topology regarding the budget issues. A device such as hub or repeater. In my case, I no longer use hub. I usually use switches. Okay, so there exists a point-to-point connection between those hub, but definitely star topology is much better to compare to a bus. Just look at the picture. When one of the connection fails, the other connection still remains continuous. So security-wise, it's a little bit safer compared to the bus technology. The ring network topology. Wow, it looks like a ring, that's why we call it a ring. As for the ring, failure of any host is the failure of whole ring. What I'm trying to imply is ring and bus is actually very similar. Okay, so it's no longer push as the one that we should able to do. The next one is a mesh topology. In terms of assurance of quality and security, mesh is the best type of topology that you as an IT engineer or as a network engineer would able to suggest to your boss. Boss, we need mesh topology. But take note, the budget would be very, very, very high or expensive. There are two types, the full mesh and the partially mesh. Okay, so it's up to you to decide which one you're going to decide. So a full or actually a redundancy of connection, but it is always the best way to be secured. Most contact call centers have a structure of full mesh. The next one is a tree topology. Okay. Tree topology is actually good. It's a little bit affordable compared to mesh. In my case, when I was the IT manager, I usually use tree. The problem is you have to make sure that you know how to manage each one of the segments, considering all the segments which is included in there. This one is the most a little bit less complicated, less expensive, but obviously this one is the good thing for you to work hard. And the last one will be the daisy chain. For me, daisy chains no longer utilized, because for the reason it was simply outdated as in terms of connection. And the last one would be the hybrid topology. Hybrid topology is a combination of ring, bus, tree. Obviously, if you ask my personal opinion, I don't want you to partake of this kind. Hybrid technology topology inherits and merits the demerits of all incorporating topologies. So it combines almost everything, which is not actually nice work. The layout is messy, the logical concept is too complicated, and it is very difficult to simply to manage. Architecture wise, we're not sure. I never tried to use this hybrid topology. Okay, hope you learned something about our discussion today. If you have any comments and suggestions, please don't hesitate to ask. And good day and goodbye.